Hi. CME update. We are watching at the sun. What is it? Sun winds velocity. And red is high velocity. And this is going on like that now since yesterday, since the CME hit Earth. And it's just munching it, our magnetosphere. That's only the velocity. Now let's go to the density. This is really interesting because if it's white, it's really low density. Watch what happens. I was watching earlier some chart and there was 1.1 parts per cubic, whatever it was. Almost nothing. Check this out. I haven't seen that thing ever being all white. And it's also for a quite long time. That's something really interesting. I was expecting some fluctuation in this CME event, but that it goes almost to zero. It's really, really, really interesting. Now let's go to the pressure. And north, south. So we are watching from the side. And I think those are really neat. You don't see them very often. Let's start from the beginning. Let's just watch it just once because I want to check some earthquakes too. And obviously you can see we are surrounded by pressure. Yeah, that's a whole lot of pressure. So let's check out some earthquakes. I guess there's something going on. Yeah, obviously. Big one. 25 minutes ago. 5.1. What do we have here in the middle? Rice fields? Doesn't somehow look like a facility which produces energy. I don't know. But anyway, we are at the Bandasi. And just the geological features already tell us there is something underneath. Another big one. 14 minutes ago, 5.9. Tasman Sea. Let's go a little bit more far out. Let's just follow those lines. Antarctica. Yeah, South Africa. 12 hours ago. 2 hours ago. The Iron Mountain is shaking. Remember, we have those colorful mines down there. $58 of the rock is iron. 7 hours, 21 hours, 1 hour. Very fast. Huh. Yeah. I guess that's not the original name of the place. Someone told them a better name. From now on, it's Belfast. Yeah, these are from yesterday. Today, 2 hours ago. Actually, we could just check a list. It's maybe easier. 4.4, 5.9, 5.1. Let's check out. Is there any? 28 minutes ago. 5.7, Indonesia. So we had 4 earthquakes over 5 point in magnitude. And this 5.7 could easily be more than 6, but it was downgraded. This is a possibility. Yeah, so there happened 2 big quakes in a short amount of time. Peru, Mexico, New Zealand, Xinjiang, 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 Xinjiang. Yeah, I would say the volcanic or the seismic activity is quite high. Let's go back to the map. And check out a little bit. Europe. Norway got hit. Bergen. No depth, yes. Finland got hit. Is it Finland or Russia? Yes, it is still Finland. Let's check it out. Peatland. Do you know what? Is it possible? I guess this is peat. This kind of peatland stuff, mineralized or this kind of petrified wood dust, or how to put it, which is in a way dielectric, so it will react to electricity. Is it possible that these structures in this peat pond came into being through electrical currents? This would explain them, because they look like dendritical patterns. Is that possible? Whoa! Yes, I think it is, because it looks like. You don't need a computer model to figure out how things look. I was reading an article about some geologists which were somehow trying to figure out. Actually, I'm searching for another piece of land which looks like similar to the one we just watched before. Actually, here. These are kind of dendritical patterns too. Yeah, an article. Geologists, they were making this kind of laboratory experiments, which sounded really interesting. And then I read the article, and it turned out that they produced their own stone. Somewhat like, they made their own rock sample and then made some experiments, and they figured out that somehow, for some reason, it doesn't behave like natural rock. So actually, they didn't figure out anything. And I really have to ask that what's the idea behind that, creating a rock? Like you just could walk outside into the yard, grab a rock, walk back in into the laboratory and put it into the machine and figure out what it's doing. I guess it would be also cheaper. Because rock is something which has a really big abundance on Earth. We are in Switzerland, close to where I was living once. 21 kilometers in depth. I think that's really deep for this region. Let's put the terrain on. Check it out. Craters. Craters on top of a mountain. Craters on the side of a mountain. Oh. Craters. Crater. Crater. Well, anyway, interesting geography we have here. Let's put the satellite back on. That's the region. I tell you one thing. Here is one of the hottest spots for geothermal activity in Middle Europe. And we have a quake really close to that. 1 kilometers in depth. And what does that mean? Never. No, but here it's like we have all the time earthquakes here. Which is funny because check it out. There's one nuclear facility here. Another one is somewhere here. One is here. And the hotspot of the geothermal activity. But that's a thermal bath. Thermal bath. Volcano. In other words. What else is going on? They're creeping up to France. And you can really see how it is connected all together. Going up here. "40 minutes ago, à les termes, Ariège, Occitanie, France." Again, 14 minutes ago, yesterday or 2 days ago, we had at the same place where we had this hot water. Interesting. I'm not surprised. It would be just really interesting if there would be other places with thermal springs in Middle Europe where we have reoccurring earthquakes in a more denser scale than we had until now. But 59 minutes ago, 4 hours, 10 hours. The yellow ones are a little bit deeper ones. The eruptions are here, and the quakes are here. Somewhat like this. Keep that in mind. I'm just telling you. I leave it here. Thanks. Bye.